Very good. Let me copy it. So it's g of x. It's x squared plus 4 for x less than or equal to 0. And what is there? 4 minus x for x greater than 0. Now let's read the question. Find the area under the graph of f only over negative 6 to 4. So negative 6 to 4. Very good. Good pick. Thank you. So notice what happens here. This interval is between negative 6 and 4, but this function breaks, if you want, or has different forms or different shapes or different equations at 0. Between negative 6 and 4, somewhere is 0. So this interval goes with the first function, and this interval goes with the second function. So in order to determine the area under the graph between negative 6 and 4, tell me how you would write it. It's okay if you're wrong. Just tell me what you think. So how will I write the area under the graph of g of x between negative 6 and 4, knowing that this portion between negative 6 and 0 goes with this function, and between 0 and 4 goes with this function? Any suggestions? Anyone? Yes, please try.
If you do g of x negative 6 through 0.
Very good. The definite integral from negative 6 to 0 from x squared plus 4 parentheses dx plus, awesome, great job, plus what?
Zero to 4.
The definite integral from 0 to 4 from 4 minus x dx. Excellent. That's the answer. Of course, we didn't finish, but that's the way we have to determine it. That's the procedure. Awesome. Great job. So then, can anyone tell us which function prime is x squared? Which function we differentiate to get x squared?
X squared over 2.
You mean x cubed. We always increase one by the power by 1, and we divide by the same number. Because when you differentiate this, you will get that guaranteed. Plus, which function prime is 4?
4x.
Very good. And this is from negative 6 to 0. Awesome. Plus, which function prime is 4?
4x.
Very good. Minus. Which function? Exactly. We increase the power by 1 and we divide by exactly the same number, because when I differentiate, that has to cancel. And this is from 0 to 4. Awesome. So let's finish it up. And that's my page 4. Luckily for me, when I plug in 0, I get 0. But then I have to subtract when I plug in negative 6. Negative 6 to the third over 3 minus 24. Plus, I plug in 4. 16 minus 16 over 2. But minus when I plug in 0, but 0, 0. So now I will determine this. So this is negative, so with negative in front, so it will be 6 to the third over 3 plus 24 and plus 8. So lazy people do this. I'm kidding. I just want to get the number and move on. And then plus 32. 104. As you know, you can always check with a calculator. Let me show you one more time, or whenever we need to show you, I will, of course. But you be very careful how you enter this in the graphing calculator, because there are two pieces. So we have math and 0. We have math and 9, sorry. No, I didn't mean that. Calm down, okay? So of course this is x. And that was 0. And the lower limit, -6. And the function is x squared plus 4. X squared plus 4. And then plus math, 9. Lower limit is 0. Upper limit is 4. Of course, dx. It's silly that the dx does not appear. You have to enter it. There is nothing in there. So 4 minus x. So when I click enter, I have to get 104. If I don't get 104, I have to go back and check my error, find my error. Okay, good. So this is one of the properties. The area can be determined integrating piece by piece, depending on where it breaks. So here it breaks at -1, so you will have from -6 to -1, and from -1 to 4, and so on and so forth. Okay, I'd like to look at something like this. Let's choose. They are helping us by showing us the graph. So they are giving us the graph, and they want us to determine the area that is shaded. So please choose one of these 4, whichever you prefer. So we can determine the area that is shaded. Anyone, please? Which area would you like to determine? (11, 12, 13, 14). No preference?
13.
Which one?
13.
13. Perfect. Good. So in 13, we have to look carefully and determine the limits of integration. So see, the two graphs, f and g, intersect at this point and at this point. So this area will be, so this is 13. So the area will be the integral, the definite integral from which x value till which x value. What do you think? It has to be from the points, from one point of intersection till the other point of intersection.
1 to 4.
1 to 4. That's it. 1 to 4. Very good. Which one is the upper function? So the area is enclosed above by one function and below by another. Which function is above? Which function touches the graph of the area above the other one? Which one?
G of x.
G of x is the green one. So G of x is here, this piece.
Okay. F of x.
Yes. F of x is right here, is the above one. So here's f of x, 4x minus x squared. 4x minus x squared. Now I have to subtract the one that is on the perimeter below the area. But I have to subtract this one, which is x squared minus 6x plus 8. So I'll put x squared minus 6x plus 8 and dx. So one more time. The graph looks something like this. This is the area. From here till here, I have function f. From here till here, I have function g. So that's why I have to subtract from function f, I have to subtract function g. From function f that is above, I have to subtract function g that is below. If they were reversed, I would have said g of x minus f of x. But f of x is above and g of x is below. Good. Now remember, I have to distribute the negative sign to all three terms. So then, the integral from 1 to 4, 4x minus x squared minus x squared plus 6x minus 8. So then we have the integral from 1 to 4, negative 2x squared in the correct order, plus 10x and minus 8 dx. Yes, this is a continuous function on 1 to 4, otherwise I could not use the fundamental theorem of calculus. So now, negative 2. Which function prime, when I differentiate this function, I get x squared.
X cubed over 3.
Very good, thank you very much. Plus 10. When I differentiate this function, I get x. Please.
X squared over 2.
Very good. And minus 8. When I differentiate this function, I get 1. Please, anyone?
X.
Very good, awesome. And of course, put in parentheses from 1 to 4. Okay. Now, do you want me to show all the numerical calculations, or can I use the calculator and get the number? You tell me. If you want me to, I'll show step by step. Is it okay if we get the number directly so we can move on to other problems? Let me know what you prefer, because I have to plug in 4 here, here, and here, and then subtract when I plug in 1, 1, 1. Do you want me to show those steps, or can I calculate with a... It's up to you. It's the same for me.
I think you can put in the calculator.
Okay, so let's do that. We just, I'm cutting back on time, but I will do whatever you want me to. And be very careful where you have to plug in the function, not the last step where we use, not the antiderivative. You have to plug in the function. So be careful. I didn't mean to do that. I meant to do this. And 9. So this is from 1 to 4. And the function was negative 2x squared. Areas enclosed cannot be negative. Area can be negative if the function is under the x-axis. But the area enclosed between two graphs can never be negative. So negative 2x squared plus 10x minus 8, and my answer is 9. So this area, where is my graph? Right here. This area enclosed above by F and below by G is 9 units. Now here, these are the same, and we will have to at least work on a couple of problems here, or at least 1, 2. They are giving us the functions, but they're not giving us the graph, which means we have to graph. We have to find the points of intersection, because without the points of intersection, I do not know how to determine the area. The area here exists between x equals 1 and x equals 4. Now I have to do the work for these problems. I have to graph both, I have to find the points of intersection, and then I have to find the integral. So, allow me to choose one here. Okay, I'm on page 5. Okay, so let's choose a simple one first. Let's say 17. And then I let you choose. So y equals x plus 2 and y equals x squared. This is an easy situation. Find the area of the region bounded. We can say here, bounded below by g of x, bounded above by f of x. Bounded by the graphs of the given equations. Okay. So first of all, we have to graph both functions. What type of function is this? And how do I determine the x and y intercepts? Can anyone tell us what type of function is this? Anyone, please? We had this in prerequisites, we graphed them in chapter R. Anyone? Can anyone identify this function for us, please? Is anyone with me? Okay, this is a linear function. And how do we determine the x and y intercepts? Can anyone tell us how we determine the x and y intercepts for this function, the x-intercept? How do I determine the x-intercept?
You plug in 0 for y.
Excellent. 0 for y, so x equals -2. So -2 comma 0. Awesome. How do I determine the y-intercept? I make x equals 0 and I get y equals 2. So 0 comma 2. I'm going to plot and graph. So -2, 0, and 0 comma 2. So this is y equals x plus 2. Now I will graph y equals x squared. We know how to graph y equals x squared. When x is 0, y is 0. When x is 1, y is 1, and so on and so forth. So this is my graph. So this is y equals x squared. As you see, there is an area enclosed by the two graphs. This is what we need to determine. But I need to determine the points of intersection. How do I determine the points of intersection? How do I determine where they intersect? Anyone remembers how to determine the points of intersection of two graphs? What do we need to do?
You have to set them equal to each other.
Thank you very much. Thank you. Thank